We will be moving on to our next question. So here it's a question based on our soaps. Okay, critical micelle concentration for a soap solution is 1.5 into 10 raised to minus 4 mole per liter. Micellar formation is possible only when the concentration of soap solution in mole liter inverse is. So here the CMC, which means critical micellar formation, okay, is is much more higher than the soap solution, which is 1.5 into 10 raised to minus 4. Slightly much bit higher than the soap concentration might give the CMC. So here the correct option for this question is 2.0 into 10 raised to minus 3. Okay, 2.0 into 10 raised to minus 3. This is the correct option for the this question. Okay. Moving on to our next question. Incorrect statements with reference to cerium. Okay. Incorrect statement with respect to cerium. Okay. The electronic configuration for the cerium is given by xenon. One second. Xenon with 4f1, 5b1, 6s2. This is the electronic configuration of cerium. Here the first option is Ce4 plus is a reducing agent. So on Ce4 plus we reduces like for cerium, xenon, 4f0, 5d0, 6s0. Okay. So there is nothing but to reduce in this. There are completely no electrons. So this might only go oxidizing. So the correct incorrect statement is this one. Ce4 plus is a reducing agent is an incorrect statement. Ce4 plus is an reducing agent. Okay. Ce in 3 plus oxidation state is more stable than in 4 plus oxidation state. We look after that. Okay. Ce3 plus will give Xe4f0, 5d0, 6s1, which is unstable. So 4 plus is the most stable one than 3 plus. So the option is wrong out there. Ce shows most common oxidation state of plus 3 and plus 4, which is also wrong. Atomic size of cerium, okay, atomic size of cerium is more than that of this. That is also wrong because cerium has lanthanide contraction. Okay. So the correct option for this question is Ce4 plus is a reducing agent, which is option number 1. Isn't that right? Yes, Ce4 plus is a reducing agent. Okay. Moving on to that. Next question. Here, a unknown compound P, when treated with hydrogen along with palladium barium sulfate, okay, which gives an unknown compound Q, on treating with concentrated NaOH and a dilute HCl, which give R plus S. R and S forms benzyl benzoate when treated with each other. So here benzyl benzoate is another spectrum, okay, another completely irrelevant to this present reaction. So let us look at this one. When treated with palladium barium sulfate catalyst, where do we have learned this reaction? This is nothing but Rosenman reduction reaction. We have earlier studied about Rosenman reduction reaction. It is that when an acyl chloride when treated with palladium over barium sulfate along with the hydrogen, it reduces to form an aldehyde. So P might be an acyl chloride. Here the only acyl chloride present in this option is option number 3, C6H5CuCl. Okay. P is C6H5, which is benzoyl chloride. Okay, this is P. We have found that P. What is Q actually? It is C6H5CHO. Okay, benzaldehyde. Benzoyl chloride undergoes Rosenman reduction, which is nothing but reduction in presence of palladium and barium sulfate to give a benzaldehyde. This benzaldehyde is then treated with concentrated NaOH and dilute HCl. Okay, where do we have that one? This is nothing but Cannizzaro reaction. Okay, we will move on to our next question. Question number 28. A mixture of NaCl, sodium chloride, and potassium dichromate is heated with concentrated H2SO4. Deep red vapors are formed. Which of the following statement is false? That's what we will move on to our reaction. That way we can easily explain this question, which means sodium chloride, NaCl, when treated with K2Cr2O7 minus, which gives nothing but chromyl chloride. Okay, CrO2Cl2. This is deep red color. This is the reaction that happens here. Okay, we will write the anionic reactions later, but we will look after this one. Okay, when this is passed out through NaOH, okay, passed out through NaOH, what happens? This NaOH gives a yellow solution with NaOH. That's true actually. When treated with NaOH, we get a sodium chromate, NaCrO3. Okay, this is sodium chromate. This is the yellow solution that is found in the test tube when chromyl chloride is passed out through sodium hydroxide. Okay, we have treated that. This is the chemical reaction for this this question. Okay, we'll look out after the options. The vapor gives a yellow solution with NaOH. That's right, it gives a vapor. Vapor contains CrO2Cl2 only. That might be a question mark. Okay, we will look after that. Vapor contains CrO2Cl2 and Cl2. Yes, that is the right one, because there is a byproduct along with the chromyl chloride, which is chloride gas. I think the wrong one is the vapors that contain CrO2Cl2 only. So the correct option will be option number 2. Okay. The vapors when passed into lead acetate and acetic acid gives an yellow precipitate. Yes, that is true, because when this vapor is passed out through lead acetate, okay, which gives a lead chromate. One second, we get lead chromate. Okay, this is the precipitate that forms when chromyl chloride is passed through lead acetate. So the correct option for this question would be option number 2. Or option number 3 actually, not 2, sorry for that. It only contains CrO2Cl2, chromyl chloride only. Okay, we will move on to our next question. Yes, this is an multi-step synthesis process in which an aldehyde is converted to alcohol, and aldehyde is also then converted to dialdehyde. Okay, and the third reaction forms to a diol. Here the reagent, what are the reagents? Okay, we will look after that one. Here the double bond present in this aldehyde is reduced to CH2OH and CHO, which is only through H2 and palladium. Okay, which means reduction of an alkene to an alkane is only done through a palladium catalyst over hydrogen. So we will write about this one. Okay, 23 question number, which is yes, there are two options regarding hydrogen over palladium. Okay, we will cancel out the both of them. first and fourth are removed. So aldehyde is converted to alcohol, which is nothing but oxidation. Here the only oxidizing agent that could be seen here is only oxidizing agent, yes, this alcohol is converted to an aldehyde along with the pyridinium chlorochromate, which is PCC. Okay, and this aldehyde is converted to an alcohol through sodium bromohydride, NaBH4. So the correct option for this question would be option number 3, isn't it? This aldehyde is first converted to an alcohol through NaBH4 reducing agent sodium borohydride, and this is oxidized to an alcohol is oxidized to aldehyde through pyridinium chlorochromate, and the alkene is reduced through palladium catalyst along H2, which gives an diol. So the correct option would be option number 3, NaBH4, PCC and hydrogen over palladium. Okay. Our next question. The number of moles of electron required to reduce 0.2 mole of Cr2O7 minus to Cr3 plus. Okay. This is the reaction here. We have to convert Cr2O7 minus to Cr3 plus. We can write this equation by when Cr2O7 2 minus 14H plus 6 electron is, this is 14 actually, 6 electrons gives 2 Cr3 plus and H2O. Okay, here 1 mole of Cr2O7 minus is converted to 2 moles of Cr3 plus here, and the oxidation state of chromium here is plus 6. It is reduced to 3 plus 6 to 3 plus. Okay, this is the reaction for this question. We have to find out the number of moles of electron required to reduce 0.2 mole of Cr2O7 minus to Cr3 plus. Okay, when 1 mole of Cr2O7 minus is reduced, we require 6 moles of electrons, isn't it right? Yes, 6 moles of electrons. What about 0.2 moles? We get 0.2 into 6 divided by 1, which is 1.2. 1.2 moles of electrons are required to convert 0.2 moles of Cr2O7 minus to Cr3 plus. So the option would be option number 1, which is 34(1). Okay, this is the correct option. For there are only 1.2 moles of electrons to reduce potassium dichromate to chromate. Our next question, which of the following statement is wrong? Okay, in highest oxidation states the transition metal shows acidic character. This is the first statement that in this question. Second one is Mn3 plus and cobalt 3 plus are oxidizing agent in aqueous solution. Okay, and metals in highest oxidation states are more stable in oxides than fluorides. According to this, all the first three ones are correct actually. Mn3 plus and CO3 plus are oxidizing agent because there are no electrons in this, and all the elements of 3D series exhibit variable oxidation state. That statement is false according to the block elements here. So the correct option would be option number 4. Moving on to our next question. The reaction which delta H is greater than delta U, change in internal energy is. We do know that this according to thermodynamics law, we have delta H is equal to delta U plus delta Ng. This delta Ng is the change of moles of gaseous reactants. That is what here we are explaining. So in our first reaction there are 2 moles of reactants and 2 moles of products. So delta Ng would be 0. In order to get a delta H greater than delta U, we need to find a positive delta N value. So this is a 0, and here 1 minus N. That means there are no reactants. Delta N is equal to minus 1, and this question there are 1 mole of nitrogen and 3 moles of hydrogen, which gives 2 moles of ammonia. Okay, and therefore delta N will be 4 minus 2, which is 2. This is a positive value, and therefore delta H would be greater than delta U. Okay. There's a slight change in this one actually. 2 minus 4, which is a negative value, and delta N G would be a negative value. So this would be delta H less than delta U, which is wrong for this question. Correct option would be option number 2, reactants of products delta N, which is 1 minus 0, which is equal to 1, a positive value. Okay, the correct option would be option number 2, calcium carbonate, which is reduced to calcium oxide. Moving on to our next question. Addition of an excess silver nitrate to an aqueous solution of 1 mole of palladium chloride tetrammonia gives 2 moles of silver chloride. The conductivity of the solution corresponds to, actually we have to find out the number of ions in this reaction. Here addition of an excess silver nitrate gives a coordination compound, which is palladium NH3 4 Cl2. Okay, this is the coordination compound formed by this one, which is then reduced to PD NH3 4 2 plus and 2 Cl minus. Okay, here this is an AB2 type electrolyte. Okay, AB2 type electrolyte, which gives 1:2, isn't it? There are totally 1 electrolyte or 1 ion in here, then 2 around here, which gives 1:2. So the correct option would be option number 3. Okay, you could easily attempt this question by doing this coordination compound complex in every reaction. Okay,